All right, we're looking at exponential functions, and the first thing to do is to define what an exponential function is. So let's do that now. So we can say the exponential function f with base b is defined by, and this is what it looks like, is defined by f of x equals b, your base, raised to the x power. So this is what an exponential function is doing. Our variable is now in the exponent. That's an exponential function. All right, and there are some special things we want here as far as b. So for b, where b is a constant real number such that b is greater than 0 and b cannot equal 1. So let's look at some examples of what this looks like. All this definition is saying is that if we have something of this form, our b has to be greater than 0 and it cannot be 1 to be an exponential function. So let's just say examples. And here on this side we're going to say expo funcs, because I don't want to write all that out again. Expo functions. And over here we'll say not an expo func. Alright, so pause the video and try to write one yourself. Let's just start out with something simple. We'll call this one f of x, and we can say 3 to the x power. That's an exponential function. Our variable is in the exponent, and our b is 3, and that's greater than 0 and not equal to 1. So that defines an exponential function. We could also have something like this, 1/3 x. 1/3 is our b, which is greater than 0 and is not equal to 1. And just to hammer it home, you could have something like the square root of 2 raised to the x power. Now, things that are not exponential functions, well, there's infinitely many of these. Something we're familiar with, an x squared. A variable is the base, so that means x could be less than 0 and it could be 1 because x is the variable. So there it is not the case. And then this one, if we have negative 1/3 to the x power, we have our variable in the exponent, but our base is what's causing this not to be an exponential function because it's less than 0. And then if we have where our base is 1. This is because doesn't matter what your x is, whatever value you put up here, your answer is always going to be 1. Alright, let's look at a graph. Let's see what a graph of one of these looks like. Let's say example 1. Graph. Let's just say graph. And we'll do a couple examples here. Part A. F of x equals 2 to the x power. We know this is an exponential function because our base is greater than 0 and it's not equal to 1, and our variable is an exponent. So you can obviously plug this in your calculator and see where everything gets plugged in. Just for this example, I want to show you I want to do a T-chart because we're going to have two examples here. We're going to have part A and part B. And what I want to do is graph these two so you can see them compared to each other. And I'm going to draw a T-chart. I just want to show you how the numbers relate to each other. And so let's do that now. So here's a T-chart, and I'm going to plug in some numbers. Let's say -2, -1, 0, 1, and 2. And then here I'm going to plug in f of x and that's equal to 2 to the x. Then I'm going to plug in g of x here. Alright, so if we start with 2 to the x, we have our x-axis and y. Now let's just do this one first. If I plug -2 into f of x, that means I get 2 to the -2 power. Actually, let's start with something easier. Let's start down here with the positive numbers, and then I'll come back. So let's start with 2. So 2 squared is 2 times 2 is 4. Then I plug in 1. 2 to the 1 power is 2. Then I said 0. 2 to the 0 power is 1. Anything to the 0 power is always 1. Alright, and then now we have to deal with these negative numbers, and this will be a little refresher. So anything raised to the anything that has a negative exponent, you always take it to the bottom of the fraction and then make it positive. So what I mean is, if we have 2 to the -1 power, then there's an implied 1 underneath here. There's an implied 1, we just don't write it typically. So if you have a negative exponent, what you do is you take it to the bottom of the fraction and then you make the exponent positive. So then you get 1 over 2 to the first power. And that works in general. So if you have b to the -n power, then you just take that to the bottom of a fraction and you make the exponent positive. So that's what will happen here. You have we're here at -1, so 2 to the -1. That means we have 1 over 2, which is 1/2. And then if you do -2, that means we have 2 raised to the -2 power. Take that to the bottom, means we have 1 over 4. And it's not super important that you it's important that you understand that you bring it to the bottom and multiply it out and make the exponent positive. But as far as writing out a T-chart, you're not going to see this on the test. I just want you to visualize what happens when we move over here. So now we have our points, and let's plot them. So let's start with the positive ones because those are easier. 0, 1. We have a point there. And then we have 1, 2. So we have a point there. And 2, 4. Then let's -1 and a half, -2 and 1/4. So this is the graph we have, and I should use different colors probably. And connecting the dots, you get this. This is f of x equals 2 to the x power. Alright, and now quickly I'm going to come over here and do this side. So if we plug in 2, so we get 1/2 raised to the second power, so that's 1/4. And then plug in 1, 1/2 to the first power is 1/2. Plug in 0, anything raised to the 0 power is always 1. And then -1 up here, so you get 1/2 to the -1. So what's actually going to happen here is it's going to flip the whole thing over and you're going to wind up getting 2. And then -2, so you get 1/2 raised to the -2 power, and that gives you 4. So what I want you to notice here is that depending on our x value and what our b is, here notice our b's are reciprocals, so they're flipped. And notice all our outputs, they're flipped depending on if our x is positive or negative. So just a little helpful hint there to show you what's going on. And then, so what we want to do is just plot these. We'll start with 2 goes to 1/4, 1 goes to a half, 0, 1, -1, 2, -2, 4. And so what we have are reciprocals of each other. This is g of x. All right, so exponential functions are used a lot in the real world. They're used in the stock market. They're used in exponential growth and decay. They're used in all kinds of minerals, determining how long an element will live. That's used in the stock market. I believe I said that already. It's used to determine the rapid. There's been a study a couple years back that was talking about how fast AI is learning, and it's an exponential curve. So there's a lot out there that exponentials are used on, and I encourage you to look those up.